The A380's engine difficulties have prompted concerns about the plane's safety. A Qantas A380 experienced an uncontained engine failure shortly after departure from Singapore in 2010. Because of the malfunction, the aircraft lost power in one engine and was forced to make an emergency landing. An Air France A380 experienced a similar engine failure over Greenland in 2017. Because of the malfunction, the aircraft lost power in one engine and was forced to attempt an emergency landing. So why does the Airbus A380 have so many engine problems, despite being the world's largest passenger aircraft? Quad-jet airliners are among the most eye-catching aircraft in the sky. They stand in stark contrast to the bulk of commercial airplanes, which are aircraft with two engines of various forms and sizes. But does this indicate that four-engine planes like the Airbus A380 are better prepared for engine failures? And would such an airplane be able to fly with only one engine? Well, a plane may fly in three different ways while in the air: ascending, descending, and level flight. An A380 is powered by four engines, each of which generates approximately 356.81 kilonewtons, 80,210 IBF of thrust. The combined thrust of these four engines is approximately 1,427.24 kilonewtons, 320,840 IBF, which propels the aircraft into the sky. To achieve level flight with a single engine, its thrust of 356.81 kilonewtons, 80,210 IBF, must deliver enough power to keep the cruise speed at Mach 0.85, 903 km per hour or 488 knots. This speed, however, is impossible to achieve with a single engine. As a result, the plane begins to slow and drag, losing height. In this case, it would be critical for the crew to restart the other engines. If not, they would need to identify a suitable neighboring airfield to divert for an emergency landing as soon as possible. This could be especially difficult with the A380, which can only fly into and out of specific airports due to its size. Overall, flying an A380 with only one engine appears to be a dangerous proposition. Indeed, flying the A380 with two engines is something that the Federal Aviation Regulations specify should only be done in exceptional circumstances. The design and development of new engines for such a big aircraft has been one of the most complex parts of the A380's engines. The A380 needed powerful engines capable of delivering the required thrust for takeoff and cruising. As a result, Rolls-Royce created the Trent 900 and Engine Alliance. A collaboration between General Electric and Pratt & Whitney created the GP7000. Throughout the early stages of the A380's operation, there were a few incidents involving engine failures or problems. These instances received a lot of attention and raised concerns about the dependability of the engines. It is important to note, however, that before they are licensed for commercial use, aircraft engines must undergo lengthy testing and certification processes. The A380 engines had a number of issues, including oil leaks, turbine blade cracks, and engine failures. These problems were not unique to the A380. They can occur with any complex piece of technology, especially during the earliest stages of operation. Engine manufacturers worked extensively with Airbus to identify and resolve concerns in order to overcome these challenges. To avoid similar incidents in the future, improved inspection methods and changes were implemented. As a result, engine longevity has improved over time. What might cause an engine to fail? Engine failure can occur due to one or more of several factors. The outcome is classified as either a contained engine failure or an uncontained engine failure. A contained engine failure occurs when anything goes wrong in the engine, but everything remains inside the engine case. Power supply problems are an example of a failure in which the engine is still operational. Meanwhile, an uncontained engine failure occurs when one or more engine components separate from the engine. These incidents are significantly more visible and might be a frightening sight for passengers seated near an aircraft's wing. In the worst-case scenario, the entire engine could disintegrate and collapse to the ground below. For instance, in November 2010, a Qantas A380 suffered an uncontained engine rotor failure, URF, of its number 2 engine during takeoff from Singapore Changi. A Trent 900 Rolls-Royce debris from the Europe collided with the aircraft, causing major structural and system damage. The flight crew handled the situation well and successfully returned to and landed at Changi Airport after completing the necessary procedures for the numerous system failures. ATSB, Australian Transport Safety Bureau. Why doesn't Airbus make its own engines? Given the firm's size and capabilities, it's reasonable to wonder why Airbus doesn't simply design and build its own engines, or possibly acquire a company that already manufactures engines to bring propulsion technologies in-house. While this may appear to be a smart concept on the surface, fully vertically integrating something as complicated as a family of current aircraft would be a very costly endeavor. Many of Airbus's suppliers also develop technologies for competitors, which benefit the company immensely. This implies that the expenses of research and development are mitigated and shared to some extent by competitors such as Boeing, which employs many of the same or very comparable technologies in its own aircraft. This explains why acquiring one of the big engine manufacturers on the market now would make little sense. Because commercial jet engines are typically made by one of just a few manufacturers used by both Airbus and Boeing, Airbus purchasing one of those manufacturers would almost certainly mean the end of Boeing's partnership with that manufacturer. In such a case, the manufacturer's engines would very certainly cost Airbus more than they did previously, as all cost-sharing and economies of scale achieved by having several clients would be gone. Because there are several suppliers, technologies are developed in a more competitive setting where innovation and cost savings are rewarded. As a result, better technologies are more likely to triumph than if Airbus created everything for its planes in a vacuum. Aside from economic or innovative reasons, developing engines in-house would cause legal issues for Airbus as it attempts to sell in the United States. Although there are certain workarounds, American antitrust laws generally prohibit airframe manufacturers from also making engines in order to prevent the formation of monopolies. However, it should be mentioned that Airbus is now developing its own hydrogen fuel cell engine. Nonetheless, Glenn Llewellyn, Airbus's vice president of zero-emission aircraft, has noted that the company's development of its own hydrogen fuel cell engine is more about researching the technology in the first place. A partner will likely be brought in later stages for ultimate manufacturing. So we are predicting that Airbus has plans to make its own engines in the future. As previously stated, Airbus is actively developing a hydrogen fuel cell power plant that may possibly be used on future aircraft. Airbus has already declared that it intends to introduce a zero-emission aircraft into service by 2035. Given the United States antitrust laws, using an Airbus-produced engine could be difficult for sales to American customers. However, Airbus has also partnered with CFM International on a separate hydrogen combustion project, so a future hydrogen-powered airframe could be offered with one engine option for American customers and two for customers elsewhere. Nonetheless, the business believes that, for the time being, the Airbus-produced hydrogen engine is mainly about technical development. According to Airbus executives, the corporation may bring in a manufacturing partner for the engine prior to any potential commercialization, but it has not ruled out totally in-house production. Till now, Airbus has collaborated with a number of engine manufacturers, and these firms collaborate to build specific engines. General Electric, Pratt & Whitney, Rolls-Royce, and Snecma Safran are the engine manufacturers for Airbus. Manufacturing collaborations include CFM International, GE and Snecma, International Aero Engines, Pratt & Whitney, Rolls-Royce, MTU, Kawasaki, Mitsubishi and IHI, and Engine Alliance, GE and Pratt & Whitney. At last, the Airbus A380 has suffered a lot of engine issues in recent years. These issues are caused by a variety of factors, including the complexity of the engines, the severe conditions in which they are frequently operated, and the aircraft's massive size. Although the A380 has a trustworthy overall safety report, the number of engine problems is alarming and could lead to more major accidents in the future.